All right, let's take a look at a practice problem. So in this case, we have a 355 milliliter soda contains 45.45 grams of sucrose. What is the molarity? And we're given the formula and the molar mass of sucrose. In terms of molar mass, for practice problems and stuff like that, you want to be able to calculate it. But I oftentimes Google it. Once you know how to, calculate the molar mass of something, you know how to calculate any molar mass. And then after that point, it kind of gets annoying to have to calculate it all the time. If you just type in the compound and type in molar mass into Google, most oftentimes you'll get the right answer. So anyways, we're taking a look at this question. Notice that this is like a word problem. This is what you're going to face in chemistry a lot. We're not just going to give you an equation and ask you and plug and chug through it. We're going to put some kind of word problem and expect you to do the rest. So many times that you're doing word problems, you're going to want to think about what you want. And what this problem is asking is the molarity. So what we want is the molarity. And remember that the molarity is the moles of the solute. In this case, that's the sugar or the sucrose, over how much solution you have, right? And so think about what pieces in your question are going to become these units, right? When we're talking about moles of sucrose, that's going to somehow come from grams of sucrose, right? Those are both talking about sucrose. And then when we're talking about the liters of solutions, that's somehow going to come from the amount of soda that we have. So there's many different ways to solve these problems. I'm just going to do it one way. You can feel free to do it whichever way you want. So I would start off by saying, okay, well, we have 45.5 grams of sucrose. And then I'm going to put under it the 355 milliliters of soda. Right. The reason that I did that is because I know at the end I want moles over liters, and I know my moles are going to come from the grams, and my liters are going to come from the milliliters. And then after that, you just start converting. So 1,000 ml into 1 liter, because we need to convert the mLs into liters. And then we need to convert the grams into moles. So we're going to take the molar mass, divide by it. Then the grams and the grams cancel out. And then there's our final answer, 0.374 moles of sucrose over liters of solution, which is equal to molar, right? 0.374 molar. Another way that you could have done this problem is you could have taken your 45.5 grams of sucrose, could have converted that to moles. And then after that, you could have divided by the 355 ml, right? Note that in this case, I'm not going to have a top unit because I just want to insert my volume down on the bottom. And then convert that to liters, and you'll get the same answer. Another way to do it would be to look at it like a plug and chug type of problem, right? So molarity is going to be equal to moles of sucrose over liters of solution. And so then you want to take a look at each individual piece and figure out how to get it. Well, our moles of sucrose is going to come from the grams. So 45.5 grams of sucrose, divide by the molar mass, 0.132924 moles of sucrose. And then we'll underline this 2 because that's our uncertain digit. If you're going to do it this way, in which you do math at pieces at a time, do not round until you get to the very end, right? So I'm going to either write out what my calculator gives me, or I'm just going to include at least 3 numbers after my uncertain digit. If I rounded this to a 3, I've inserted error into the problem, because every time you round, you insert error into the problem. And then there's a chance that your final answer will be incorrect because you've added error in multiple areas, and then you don't get to the right answer. So then there's our numerator for that problem. And then since we're doing a plug and chug type of problem, we want to then figure out what the bottom is. Well, the bottom is going to come from that volume. So we'll take 355 milliliters and then 1,000 milliliters over 1 liter. Milliliters and milliliters cancel out, 0.355 liters, right? And then you simply take that, plug it into your plug and chug problem. So then you do 0.132924 moles over 0.355 liters, and then you get the same answer of 0.374 molar. So as you can see, there's multiple different ways to do any problem in chemistry, especially once we start getting a mixture of conversion units, plugging and chugging, that kind of thing. So let's just write that down. Many ways to solve a problem. However, showing your work clearly, right, in a clear, organized manner is as important, if not more, than getting the right answer. Right. While we are in an academic setting, right, and the right answer is available to you. So if you did something wrong, you get the wrong answer, and you know that you get the wrong answer. However, in a real life application, you're not going to know what the right answer is. And so it's really important that you show your work. That way you can justify what your answer is. Anybody else should be able to take a look at your work and quickly and easily be able to tell why you did what you did at each step and how you got to your final answer. If somebody looks at your work and they have no idea what's going on, it does not matter what your answer is. Your work is basically useless, and so is your answer.